The model view controller pattern, or the MVC pattern for short, is about managing user interfaces and the technology behind user interfaces. Now, when I say user interfaces, could be a thick GUI, like if you're building a Windows or a Mac or a Unix or Linux client. It could be a web interface as well, especially when we're talking about JavaScript, rich JavaScript clients. Certainly, it could be a mobile interface. Any of those are applicable. The There are cases where this is less applicable, so to be clear there, but it's a very good pattern for how do I control a interface with a otherwise unknown, uncontrollable client on the other side. And so to start with this, let's talk about an analogy, if you will, and kind of set up the reason why MVC is helpful. So imagine you have a diner, and you have Don's Diner out there, and he's really into alliteration. So Don has Wally, Wanda, the waitstaff, Charlie and Chelsea, the chefs, and Carrie, the cashier, who works for Don. And we want to look at a very specific interaction that happens at Don's Diner, that to show why MVC is important. So we all know when you go out to eat, the customer is going to go to the wait staff, Wally or Wanda, and they're going to give them an order. And then typically what you expect to happen is that order is going to get back to the chef, and they're going to say this is what the person ordered. The chef's going to make that food, and they're going to give that food to Wally and Wanda, and they're going to give it back to the customer. Doesn't seem like that big a deal, right? You have the client, you have an interface, you have a back end, if you will, that work together to be able to complete that transaction. But when you consider scaling this up, the interaction between the wait staff and the kitchen are very, very interdependent on each other. The wait staff has to sit around and wait for the cooks to be able to attend to the the order. If they're not listening, I can't just say, "Hey, somebody wants a burger," and walk away. They have to hear that, acknowledge that, and have that in their work queue. And then the flip side of that is when the work is done, that burger is cooked. We don't want the chef running around looking for the wait staff. We don't want that sitting around getting cold. We want that interaction to be seamless for both sides, yet at the same time be timely on both sides. And so if these two roles are overly interconnected, directly interconnected, could constantly be waiting on each other and losing a lot of efficiency in the meantime, and then unable to attend to different tasks. I mean, again, you want your wait staff socializing with your customers. They want them to be happy that they're around. You don't want them to be rude to the customers, but then again, then the chefs be running around looking at them. So let's apply the tenets of the model view controller pattern to this. So again, we talked about the interaction where the customer orders food. But instead of going directly to the wait staff, since Don's wife is an IT consultant, knows about the MVC, she's going to give him a computer. And the wait staff is going to enter orders into the computer, which then feed the chefs on demand. So as the chefs finish one order or they're ready to look up, they can just see a screen to know what they're going to be making next. And when that food is ready, instead of running around and looking for the wait staff, they're going to just signal. That's what the little dotted line means here. Maybe they'll hit a bell, or maybe they'll put in the computer like, "Hey, this order's done," and then either the wait staff will hear the bell, or they'll get a text or something like that from the computer that tells them to go pick up the food and deliver it to the customer. And so the model view controller sets up the wait staff as being the view. That's your screen, your web page, your touch screen, your mouse and keyboard screen. The controller is this new entity which helps organize the work between the two of them. So the actions by the user gets translated into things the controller does, which doesn't necessarily resemble what the user's asking for. The user's asking for, a meal. Well, that on the back end might say, "Hey, let's have one chef start a salad, another chef will start boiling some water, another chef start, all these different things that could be happening." It allows us to break up that work and not have the view or the customer be aware of that. And then the other real key part of this is the model is not responsible for delivering food to the customer or even the wait staff. So if you have ever worked in a restaurant, you might be aware that there's a lot of things that the wait staff do to finalize a meal. They might be actually be making a salad or something like that. They might be adding garnishes to the plate. They might be doing a few things to transform what comes out of the kitchen to the thing that gets presented to the customer. And so, formally speaking, a long time ago, Java defined the model view control pattern as part of its enterprise architecture pattern. And so, this formally, you can look at it as saying, like, okay, well, the MVC is saying you have a model which encapsulates the application state, responds to state queries, exposes application functionality, and notifies views of change. And so, this is much to what we've seen so far. When you do an object-oriented analysis, you come up with a model which is supposed to represent that application in a pure form without any specific user demands, without any specific user interfaces. It's just the way the system should behave if left alone in an omnipotent and omniscient state of what's going on in the rest of the world. But we know that's not true, so we have views, which allows the system to render the state of that model to external users. It probably is humans, but it could be other software systems as well. And then that view is responsible for basically organizing changes to the model or queries of the model or things the alter the flow of control, and those go through the controller. The controller is that bridge between what the user wants and how those changes should be made in the model. So you can think of it this way. Um, if you hit the gas pedal on a car, in theory, in the old days, there was like a little spring that would pop open more gas going to the engine, and the car went faster. But today, in the modern world, there's a whole computer in the middle of that organizes. If you hit the pedal, maybe it's electric, maybe it's gas that kick off, especially in a hybrid car. Maybe it's using some pumps to accelerate that. It's kind of like power steering. You used to steer directly, and it was very, very heavy, and now the power steering helps that in some way. And certainly the brake pedal is very, very intelligent. If you slam on the brakes and the brakes would lock up because of that, there's a system that says, okay, well, we're going to stutter that brakes to make sure they don't lock the wheels and you actually stop on time. And so that's the idea of the controller, is you translate the user requests into something a little bit more meaningful with the model without having to conform the model to the user request. The model does what the model does, and the controller kind of translates that. And so another advantage of that MVC then is not just simply that lack of dependencies back and forth between those, but allows us some flexibility in how we can expand the system. And so, for example, a big trend these days, especially post-pandemic, is to add in technology to the ordering system. And so I can put an LCD screen which enters orders just as the same way that the wait staff did before. In fact, that LCD screen might be what the wait staff uses directly. So I can have the wait staff spend more time with my customers. I'm not going to fire them. Everybody loves Wally and Wanda. But I can have them spend more time with the customers and spend less time fiddling with the computer in the back room. They can do it on the device themselves so the customers can do it. And then Wally and Wanda can just hang out and chat and be popular. And this also opens up the notion that if the food's ready, I could go and text that device. So now for takeout orders, I can have my I can hire more kitchen staff to cook food because that's really important, and then keep all my wait staff doing what they do best, serving the customers, and let customers come and be told when the food's ready, and they can pick it up themselves. The chefs can just set it by the counter or on a special shelf or whatnot. So that makes a ton of sense. And the great part about it is as I expand my system out and open up new technologies like that, the only thing that changes is the presentation tier. How I control and do the work stays pretty much the same. There might need to be in different paradigms slightly different responses, slightly different behaviors that occur, but those can just be configured in and added on. We can just say, hey, when you cook the order, you know maybe one time, if an order says in, it goes on one shelf, and if it's out, it goes on another shelf or something like that. Or you can have the controller, wrap. I mean, there's all sorts of things you can do to solve that. All sorts of other patterns that could come into play. So the big thing about the model view controller is this idea of separation of duties. You're going to have a model that can be made and stay pure, that just does quote unquote business things or school things or government things or military things or whatever that domain is. When we say business, that's kind of what it's implied to be, is whatever that domain is. And then we can customize the behavior of the of that model based off the experience. The controller and the view can customize that to have it be differently. I mean, your video games can be slightly different on a console than on a PC. If you're into video games, your healthcare system is going to be slightly different if you're at a clinic than a hospital. The big thing here is the MVC helps promote reuse, reuse, reuse. We can share as much of that model as possible. Even more of it now that we have that controller sitting in front of it. That should not have to change very often, but we also enhance expandability along the way. We're not limited to a website or a desktop application or a mobile application or whatever comes next. I mean, if the metaverse takes off and we're suddenly doing everything in virtual reality, well, now we can take that model and expand to that new paradigm. So the model view controller is really the way most things are built that have user interfaces, and getting used to that idea is super important. That signaling out is really important and vital, that the model is not trying to format things for the screen. The model has its own definition, and the screens are responsible for displaying that. And so if you keep that in mind, you'll make applications that are much more resilient and much more flexible in the long run.